Hello everyone, this is Aashish Lama. I am a bachelor's of I am a Ulster University student. I studying Bachelor's of Science honors computing system. My student ID is 20103522. Uh, Coming to the point, in this screencast, I will be presenting the design and implementation of a relational database for a car repair business. The aim of this database is to model how customers, their cars, service bookings, and mechanics interact in a real garage environment. I will start by explaining the entity relationship diagram and move on to the database schema and their limitations and assumptions as well. Then after, I will demonstrate the database, how database was implemented in MySQL, how the data was populated, and finally, I will work through uh, several SQL queries that support common business tasks. So coming towards again the entity relationship diagram. The ER diagram is based around five main entities: customer, car, service, mechanic, and service mechanic. Uh, a customer, a customer represents anyone. A customer represents anyone who uses the garage. Customer may have multiple cars or none at all, and they may also have multiple service bookings over time. But each car is uniquely identified by its registration number and is always linked to exactly one customer. However, a customer can own multiple cars and creating a one-to-many relationship. The service entity represents a service booking. Every service must be linked to a both car and a customer because a booking cannot exist without knowing who it is for and which vehicle is being serviced. Customers and cars, however, can exist in the system without any services. The mechanic entity stores employee details. Mechanic do not need to be assigned to a service immediately, so that participation in services is optional. Uh, Here's employee ID, name, employee phone number, and the grade. In a real workshop, multiple mechanics can work on a single service, and a mechanic can work on many different services. This creates a many-to-many relationship, which is resolved using the service mechanic table. This table links uh, services and mechanics and also stores the time each mechanic spent on a specific service, since that information belongs to the relationship itself rather than either entity. Now moving towards the database schema and normalization. Based on the ER diagram, the database was implemented using the following tables like customer, car, mechanic, service, and service mechanic. Each table has clearly identified primary key and foreign key are used to enforce the relationship between tables. All non-key attributes depends only on the primary key of the table, and there are no transitive dependencies. As a result, the entire schema is normalized to 3NF, which is third normal form, which removes the redundancy and helps maintain data consistency. Now let's move towards the assumption and limitations. Several assumptions and were made during the design, each where each car is assumed to have a single owner. Customers and mechanics can exist in the system without having any associated services. Service record can also be created before mechanics are assigned to it. Some attributes such as phone numbers, email address, next service date, and time spent are optional because that information may not always be available. There are some limitations as well. The database does not track payments, servicing costs, maintenance schedules, or historical car ownership. Each service record represents a single job, even though in a real garage, multiple tasks may be completed under one booking. Now, I will Let's move towards the database implementation in my SQL Workbench. I implemented the database using MySQL Workbench, and now I will walk through the main parts of the SQL script. I started by creating a car service, the database. I started by creating and selecting the car service workshop. Uh, I temporarily disable foreign key checks, and drop existing tables, uh, triggers, and procedures to so the script can be rerun safely during development. Next, I created core tables. Uh, yep, the customer table uses customer ID as a varchar 20 primary key and stores the customer's name, email, phone number, and uh, a unique constraint is a unique just sorry a unique constraint is applied to the email column. Now the car table uses registration ID or registration number. Here you go. Registration ID or registration number as the primary key and includes the make, model, uh, date of manufacture, and customer ID. Yeah, customer ID uh, as its uh, date of manufacture, and a foreign key linking the car to its customer. I use like on delete, restrict, on update, cascade to support joins. The mechanic tables, the mechanic table stores employee details such as name, phone, phone number, and grade. A check constraint, a check constraint uh, restricts the grade to values such as apprentice, mechanic, senior mechanic, and trainee. The service table stores service bookings uh, and includes the car registration, uh, drop off date and time, and work required, mileage, next service date. Registration column is the registration column is a foreign key. Yep. The registration column is the foreign key refreshing the car table, and an index is added on drop off date and time. Uh, drop off yeah drop off date and time to support date and time and to support database queries. The service mechanic table resolves the many-to-many relationship between services and mechanics. It uses a composite primary key and applies on delete cascade on update cascade. On delete cascade. So mechanic assignments are removed automatically when a service is deleted. I also created a mechanic unavailability table to store periods when mechanics are unavailable with a check constraint. So, to ensure that end date cannot be earlier than the start date. To generate service IDs in a consistent format, I added a helper table called ID sequence. I guess it's ID sequence. Here you go. Yeah. Uh, which is used by a stored procedure to generate IDs such as S2 2025 Yep. And two triggers were created. Yep, there are. One automatically sets the next service date to 1 year after the drop off date for annual services if no next date is provided. The second trigger prevents assigning a mechanic to a service if they are marked as unavailable on that date. Finally, I created procedure. Okay. I created a stored procedure USP. Just a moment. Yep. I created a stored procedure called USP Add Service Booking, which generates a new service ID and inserts a new service record using the supplied parameters. Now, moving towards the data population, uh, scrolling to the insert statements. Here you go. Yeah. Once the structure was complete, I populated the database using the data from the provided access Excel file in the coursework. Customers were inserted first, as you can see, uh, followed by car links linked to their correct customers. Next, mechanics were inserted and with their IDs and contact details contact details and grades. Service records were then inserted with the dates, uh, times, work descriptions, mileage, service date, next service date. Finally, the service mechanic date table was populated with mechanic assignment and time split values. At this point, uh, running select queries shows that the data in MySQL matches the original spreadsheet, but is now properly normalized. Yep, here you can see. Now, moving towards the business process, uh, I will now demonstrate. I will now demonstrate the SQL queries that support task 4, task 2, and the first task. Yeah. That support common business questions. Task 1 lists all services with customer and car details, giving a clear overview of each booking. Here you can see the drop of date, service ID, drop of time, and all. The task 2 shows how many services. Task 2, let's run it. Yep, it shows like, did I do? Yep. Uh, how many services each mechanic has worked on. A left join inserts mechanic with no service still appear. Task 3 lists the task 3 lists all services on a specific date uh, and shows which mechanic worked on each one using group concat to display multiple mechanics in a single row. And the fourth task query calculates the total number of hours spent on each car. Time values are converted to hours, and Kowalski ensures cars with no work, so zero. The fifth task query, the fifth task query identifies mechanics who have not worked on any service, which can help identify new or under utilized staff. So there were no such mechanics name. That's why the table is blank. So to conclude, let's get back to the ER diagram again. So to conclude, I designed and implemented a relational database for a car service company using MySQL. Started with an ER diagram, converted it into a normalized relationship schema, and implemented it using appropriate keys, constraints, indexes, triggers, and stored procedure. I populated the database and with real data and created SQL queries that support typical business and reporting needs. So this concludes my screencast. Thank you for watching. Have a good one.